Part 5. Commissioning the equipment. Chapter 1. Commissioning an NE. 1. Powering on the equipment. Before powering on the equipment, ensure that the following requirements are met. 1. The equipment hardware installation has been completed and has passed the installation check. 2. The input power is available. 3. The input power has been turned off. 4. The system power and ODU power switches on the PXC and IF boards respectively are turned to O, which means off. Connect a multimeter at the input power supply, for example, the output terminal of the cabinet power distribution box, to test the voltage and polarity of the input power. When the nominal voltage of the input power is negative 48 voltage, the test voltage should be negative 57.6 to negative 38.4 voltage. When the nominal voltage of the input power is negative 60 voltage, the test voltage should be negative 72 to negative 48 voltage. Then turn on the input power. Set the system power switch on the PXC board to I. Set the ODU power switch on the IF board to I, that is, close the circuit. The equipment needs 3 to 5 minutes to fully start. 2. Logging into the NE and modifying the NE ID. After the equipment is normally started, start the web LCT for configuring the equipment. Note: the LM system used for demonstration in this course is Web LCT V2R4CO2B019. The actual commissioning depends on the version of the MM system you use. Use a network cable to connect the network port of the computer to the NM port of the Optiox RTN 600. Set the IP address of the computer. The IP address of the computer is in the 129.9.0.0 network session. The subnet mask is 255.255.0.0. For example, 129.9.0.12. Double-click the Web LCT icon on the desktop to display the Web LCT interface. The default username is admin, and the password is T2000. Click Login to enter NE list. Click NE Search, and the Search NE dialog box is displayed. The default domain is 129.9.255.255. Click the Search NE button to start searching NEs in the default network section. After the NEs are searched, click End Search. Then click the Add NE button. A dialog box is displayed indicating that the operation is successful and confirms if you want to log in to the NE. Click OK. Click Cancel in the Search NE dialog box. The added NEs are listed in NE list. Click the NE you are going to log into. Then click the NE Login button. The NE Login dialog box is displayed. Enter the default username, which is root, and the password, which is password. Click OK to log into the NE, and you can view the information of NE ID, NE name, equipment type, alarm status, gateway type, gateway IP address, communication status, and login status. Then click NE Explorer or double-click the NE in NE list to enter the NE Explorer interface. Select the NE from the object tree. Choose Configuration NE attribute from the function tree. Refer to the network planning and modify the NE name and NE ID. It is recommended that you add the NE ID before the NE name. Click Apply to modify the NE name. Then, click Modify NE ID and enter the NE ID specified in the network planning. Click OK. A dialog box confirms if you want to make the modification. Click Yes. The NE is reset. Close the NE Explorer and remove the NE from the NE list. After the NE is reset, search and add it again. Note that the name and ID of the NE have been modified. Then log into the NE. Open the NE Explorer. 3. Quick configuration. Note: 1. Quick configuration clears all the configuration data at the NE side. This operation is applicable to the initial installation and commissioning only. 2. Quick configuration is applicable to PDH microwave. Ensure that all boards are online. When the service board contains line boards or more than 2 IF boards, quick configuration is not supported. 3. The following operations are carried out on a 1+0 non-protection system. For a 1+1 protection system, you need to configure the IF 1+1 protection before you configure IF attributes. Display the NE Explorer. Select the NE from the object tree. Choose Configuration, Quick Configuration from the function tree. The Quick Configuration dialog box is displayed. A dialog box confirms the operation, and click Next. The dialog box confirms the operation again, and click Next. The NE Panel dialog box is displayed. Confirm the board configuration and click Next. Referring to the microwave design, set the parameters of the IF attributes. Click Next. Select the time slots as planned. Click Next. Click Clock Configuration and enter the clock configuration data as planned. Then, click Configure AutoWire and enter the AutoWire phone number as planned. Click Next. Confirm the correctness of the configuration data and click Next. Click Apply. The web LCT automatically issues all of configuration data to the NE side. Click Close and the configuration is completed. Select the NE from the object tree. Choose Configuration, NE Time Synchronization from the function tree. In the display dialog box, set Synchronous Mode to NM. Click Apply. Select the NE from the object tree. Choose Configuration, Alarm, Alarm Suppression from the function tree. You can select Suppressed or Not Suppressed to suppress or not suppress certain alarms. Click Apply. To restore the alarm suppression to the initial configuration, click Default and then click Apply. Select the NE from the object tree. Choose Configuration, Performance, NE Performance, Monitor Time. In the NE Performance Monitor Time tab, select the NE that you want to set. Select Enable for a 15-minute performance monitor and 24-hour performance monitor. Click Apply. 4. General Configuration. Log into the NE and display the NE Explorer. Add the PXC board first and then add other boards. You need to add boards first. Right-click the slot and add a board. After all the required boards have been added, select the NE in the object tree. Choose Configuration, IF 1+1 Protection in the function tree. Click New to open the Create IF 1+1 Protection dialog box. Set the parameters according to the network planning. Take HSB protection as an example. The protection group number is 1. When the equipment is configured with 2 IF 1+ protection groups, the protection group number can be modified. Click the Working Mode drop-down list and you can choose SD, FD, or HSB. Select HSB in this case. You can choose revertive or non-revertive in the revertive mode drop-down list. The WTR time is 600 seconds by default. You can modify the WTR time based on the network planning. By default, the reverse switching is set to enable. According to the network planning, select the IF board in slot 5 as the working board and the IF board in slot 7 as the protection board. Click OK. Then, in the IF 1+1 Protection tab, the created IF 1+1 protection is displayed. The upper protection group pane shows the protection groups, and the lower slot mapping relation pane shows the mapping relation between slots. Relative attributes are displayed in the pane. Select the main IF board in slot 5 from the object tree. Choose Configuration, IF Interface from the function tree. In the IF Attribute tab, double-click Radio Work Mode and select the mode as planned. Modify Radio Link ID. Click Apply. Then click Query to check if the setting is successful. ATPC is disabled by default. Select the main ODU in slot 15 from the object tree. Choose Configuration ODU Interface from the function tree. In the Radio Frequency Attributes tab, double-click Transmit Frequency and enter the transmit frequency as planned. Select whether to set TR spacing based on the microwave design. Click Apply, then click Query to check if the setting is successful. click the Power Attributes tab, double-click Transmit Power and enter the transmit power as planned. Click Apply. Click the Advanced Attributes tab, double-click Configure Transmission Status and select Unmute. Click Apply, then click Query to check if the setting is successful. Select the standby ODU in slot 17 from the object tree. Choose Configuration, ODU Interface from the function tree. Click the Advanced Attributes tab. Set Configure Transmission Status to Unmute. But as the ODU is the standby ODU, the actual transmission status is still mute. Select the NE from the object tree. Choose Configuration, Auto Wire from the function tree. Enter the planned telephone number in telephone number. Select the auto wire port. Click Apply. Select any time synchronization from the function tree. In the display dialog box, set synchronous mode to NM. Click Apply. Select the NE from the object tree. Choose Configuration, Cross-Connection Configuration from the function tree. Click New. The Create SDH Service tab is displayed. Referring to the network design, set the parameters. Select the planned service level in the level drop-down list. Select VC12 in this case. Select Bidirectional in the direction drop-down list. Select the PH1 board in slot 8 in the source drop-down list. Enter 1 to 4 in the source time slot range field. Select the IF board in slot 5 in the sync drop-down list. Adopt the default values for sync port and sync VC4. Enter 1 to 4 in the sync time slot range field. Click OK. You can check the attributes of the created service in the Cross-Connection Configuration tab. You can click Create SNCP in the Cross-Connection Configuration tab to create the SNCP service. In the Create SNCP Service dialog box, configure the parameters as planned. The attributes you need to set include service type, level, derivative, mode, direction, hold-off time, and WTR time. Then set source, source port, source VC4, and source time slot range, respectively, for the working service and protection service. Finally, set sync, sync port, sync VC4, and sync time slot range. Click OK. You can check the attributes of the created SNCP service in the Cross-Connection Configuration tab. Select the NE from the object tree. Choose Configuration, Clock, Clock Source Priority. Click Create. The Add Clock Source dialog box is displayed. Referring to the network planning, select the clock source to be added. Click OK. You can change the clock priority level by selecting the clock source and clicking the up and down button. Click Apply. Choose Configuration, Clock Subnet Configuration from the function tree. In the Clock Subnet tab, set Affiliated Subnet and Protection Status as planned. Click Apply. Also referring to the network planning, set Clock Quality, SSM Output Control, and Clock ID status. Following the method introduced in the Quick Configuration, adjust the Alarm Management function. Enable 15-minute performance monitor and 24-hour performance monitor. For detailed service configuration, refer to the Optiox RTN 600 Radio Transmission System Configuration Guide. 5. Relevant test interfaces. 1. E1 Loopback. Select the PDH interface board from the object tree. Choose Configuration, PDH interface from the function tree. Set the loopback status of the path as required. You can select non-loopback, in-loop, or out-loop. Click Apply. Click Query, and you can check if the setting is successful. 2. Transmit frequency and transmit power. Select the ODU for which you want to query the transmit power from the object tree. Choose Configuration, ODU interface from the function tree. Select the Radio Frequency Attributes tab and the Power Attributes tab. Click Query. The actual transmit frequency and actual transmit power are displayed. The actual values should be the same as the preset values. If the actual values are different from the preset values, record the type and the sequence number of the ODU and contact Huawei engineers at the local office. 3. Transmit, receive optical power. From the object tree, select the optical interface board for which you want to query the optical power. Choose Performance, Current Performance from the function tree. Set the options for querying the optical power performance. Monitored object filter condition, all. Monitor period, 15 minutes. Gauge, launched optical power and received optical power. Display options, maximum minimum value. Count, do not select any item. Click Query. Browse the optical power performance in the window. After you complete the NE commissioning on the two ends of a hop of a microwave link, you can start the hop commissioning, including aligning antennas. Chapter 2. Hop commissioning. 1. Aligning the antennas. The tools and instruments you need for aligning antennas are BNC cables, digital multimeter, and wrench. The following operation considers aligned 0.6 meters antennas as an example. When the antenna is of a different diameter, please refer to the relevant document. Note: before aligning the antennas, ensure that the ATPC function at the two microwave stations is disabled in order to maintain a fixed transmit power of the antenna during the commissioning. When the distance between the two stations is long, more than 2 kilometers, you need to place the antennas horizontally in the beginning. When the distance is short, you need to finally adjust the elevation angles of the antennas according to the actual situation. How to align the antennas? 1. Use the BNC cable to connect the multimeter to the RSSI port of the ODU. If there is no BNC cable, you can connect the multimeter directly to the RSSI port of the ODU. 2. Adjust the azimuth angle of the antenna. Keep the remote antenna fixed. Loosen the nuts on the horizontal adjustment bolt of the local antenna. Rotate the antenna around the pole. Usually, when you rotate the antenna, 3 peak signals can be obtained. The middle peak signal has the highest voltage. 3. Adjust the elevation angle of the antenna. Properly loosen top and bottom connection bolts between the antenna and the mounting bracket. Rotate the elevation adjusting bolts to adjust the antenna elevation. The range is -15 degrees to +15 degrees. In the 3 directions where the 3 peak signals appear, adjust the elevation angle of the antenna until the 3 receive levels reach their respective maximum values. Then adjust the antenna to the position where the receive level is the highest of the 3. Tighten the antenna. When you tighten the antenna, ensure that the receive level remains at the maximum value. 4. Refer to steps 2 and 3 and adjust the remote antenna. When the remote receive level reaches the maximum value, tighten the remote antenna. Repeat steps 2 to 4 to make the receive levels at the local end and the remote end reach the planned value. Tighten the antennas at the two ends. During the tightening, ensure that the receive level is at the maximum. Use the multimeter to test the receive level values at the two ends. Refer to the receive level values and the received signal level curves of the ODUs at the two ends and read the current receive power values. The actual receive power should be the same as the planned value. The difference should range from -3 dBm to +3 dBm. Note: for a 1+1 protection system, it is suggested that you turn off the power of the standby ODU before you adjust the antenna. 2. Relevant test interface. 1. Testing the ECC. Log into the web LCT and start searching NEs. If the ECC is normal, the web LCT can search the local NE and the remote NE. To add NEs, you can hold down the control key and use the mouse to select multiple NEs you want. Click NE Login. Select the Use Same Username and Password to Login checkbox. Enter the username and the password. Click OK. If the login status of the two NEs displays logged in, the ECC test is successful. 2. Testing the auto wire phone. Dial the auto wire phone of the opposite station. If the call is successful and the conversation quality is good, the auto wire phone test is successful. 3. Testing the IF 1+1 protection. Select the NE from the object tree. Choose Configuration, IF 1+1 protection from the function tree. Make sure that the status of the IF 1+1 protection is normal. That is, make sure that the IF board in slot 5 is the working board at the equipment side. Turn off the power of the main ODU and check the switching status. If the IF board in slot 7 is displayed in the active board of device fields, the switching is successful. To test the IF 1+1 protection switching, you can also right-click Working Board or Protection Board in the slot mapping relation pane and select Forced Switch to Working or Forced Switch to Protection. After the test is completed, clear the protection switching. 4. Looping back the optical interface. Select the optical interface board on which you want to perform the loopback operation from the object tree. Choose Configuration, SDH interface from the function tree. Select By Function and select the required loopback mode from the drop-down list. Click Apply. You can click Query to view the setting result. The optical interface loopback is automatically released 5 minutes later. You can select the NE from the object tree and choose Configuration, Automatic Disabling of NE function from the function tree. In the Automatic Disabling of NE function tab, you can set auto-disabling and auto-disabling time of the loopback. Click Apply. Note: Optical interface loopback is an operation with possible dangers. It must be carefully implemented by a qualified engineer under an authorized permission. 5. Testing the PRBS. Select the tributary board you want to test from the object tree. Choose Configuration, PRBS Test from the function tree. In the PRBS Test tab, select the port you want to test and set direction, duration, measured in time, and accumulating mode. Click Start to test. The system displays a dialog box confirming the operation. Click Yes. The value of the bit errors generated during the test is displayed in the total PRBS field. 6. Querying the software version. Select the NE from the object tree. Choose Report, Board Information List, Board Information Report from the function tree. The Board Information Report interface is displayed. Click Query. You can view the software version and other board information. 7. Querying alarms. Select the NE from the object tree. Choose Alarm, Alarm Browse from the function tree. There are two tabs named Browse Current Alarms and Browse History Alarms for you to view current alarms and history alarms on the NE respectively. By default, the Browse Current Alarms tab is open. Click Filters and set the required filtering conditions. Then, you can view only the alarms that you want. Click Save As to save the current alarms to a file. Click the Browse History Alarms tab to view, query, or save the history alarms. 8. Querying performance events. Select the board for which you want to view the performance events from the object tree. Choose Performance, Current Performance, History Performance from the function tree. Set the parameters to view the current or history performance events on the board. 9. Querying abnormal events. Select the NE from the object tree. Choose Alarm, Browse Abnormal Event from the function tree to view the abnormal events on the NE. Click Filter and set the required filtering conditions. Then, you can view only the abnormal events that you want to view. After the commissioning, ensure that the following requirements are met. 1. The NE ID complies with the network planning. 2. The NE time is synchronous with the NM time. 3. The board status is normal. 4. The software version is correct. 5. The clock priority level is set as planned. 6. The current alarms have rational reasons. 7. The cross-connection, IF 1+1 protection, and board 1+1 protection are configured as planned. 8. The IF board and ODU are configured as planned. Make sure that the equipment operates normally and all the items to be checked comply with the network planning. That's all for this course. Thanks for your attention.